Hello, my name is Mike Simmons and I'm with the Tennessee Job Training and Safety Program. I'm here to talk to you today about wooden pole inspections. The Tennessee Job Training and Safety Program conducts meetings all over the state, and since we're not able to come to you for this topic face-to-face, we're doing a video presentation of this program. I hope that you'll get a lot out of this program, and I hope that this will help you to remember to do the things that you need to do out there to stay safe when you're working in and around and on wooden poles and structures. Now, as always with our normal monthly meetings at Job Training and Safety, we have a session where we talk about near misses and close calls. And even though we're not able to be there with you to talk to you about this face-to-face, we do want to encourage you to have a discussion that covers any near misses, close calls, or actual accidents or injuries that may have occurred in the last few weeks or days, because communication is the best way we can do it. And discussion of these near misses and close calls, reminding people about a condition that could be more common than you think, can go a long way toward preventing honest-to-goodness injuries and perhaps even fatalities. So I want you to pause the video for a few minutes, have a frank discussion, don't be afraid to talk about it, and cover those near misses, close calls, or accidents. Share that information. It's always better to tell somebody something they already know than to fail to tell them something they need to know. So I'll give you a few minutes to talk about that. Well, I hope that you pause the meeting, and I hope that you did have a good discussion about that. I would encourage you to communicate and talk about those near misses and close calls. It's not about pointing fingers. It's about identifying situations and conditions that might be more common than you think, and letting others benefit from your experience and knowledge. If you're not going to do it in a meeting setting like this one, then do it while you're in the crew room or out at the loading dock or the warehouse or out on the job. Just make sure you communicate those things to your coworkers and give them the opportunity to take steps to avoid that potentially hazardous situation. So let's get into what we're going to talk about, and that's inspection of wooden poles. A thorough inspection of any wooden pole is a critical and mandatory step when preparing to climb that pole. This includes the hardware, the equipment, any obstruction or hazards on the pole or even around the pole. And the final step of an inspection and testing is inspection and testing of the pole itself, physically determining whether or not it has the integrity to be able to support you or the intended load or stress. This is a quote from a gentleman named Philip B. McGee. He writes an article, and it's published in IP Magazine. I suggest you look this article up and read it in length. It's got some more detail in it. Remember that poles should be inspected not only prior to climbing, but also when working out of a manlift device or while using a digger derrick boom. If tension must be changed, consider how it will affect the pole and if the pole will be able to handle the change in tension. Well, what are we talking about by change in tension? Well, you could be tightening up a guy, you could be adding a service drop, you could be adding conductor, removing conductor, changing conductor, releasing conductor, or repositioning it. Once you do that, then you remove a potential support source for that pole. It's not only a good suggestion and good work practice, it's actually the law. Appendix D in 1910.269 covers the methods of inspection and testing wooden poles. And Section 2 of Appendix D states that a qualified employee shall inspect wood poles for the following conditions. 1. you're going to look at the general overall condition of the pole. You're going to look for cracks and holes that may indicate a weakening or damage to the pole. You're going to look for shell rot and decay. Is there a significant change in the diameter of the pole? Is there less pole there than when it started, and how much less? You want to look for knots or deformations in the grain of the pole. Sometimes poles don't get caught and recognized as they go through the construction and treatment process. Once they get out into the field and get ready to put up, they may have a knot or a bad portion of grain, and that could be a weak point. You also want to be aware that it may not be immediately a problem until you change the angle of the strain on the pole, or you add conductor or add strain. So be aware of the actual grain and the way the pole is put together. Depth of setting. How deep in the ground is it? Is it deep enough? Is it too shallow? Has it changed since it was originally installed? And what about the soil conditions? Are they sufficient to be able to give you good compaction, to be able to hold the pole upright and to support its own weight? Has the soil eroded, or has it had additional moisture or water added to it? Do you need to use some tamping material or bring in additional soil to get a good hold on that pole when you put it in the ground? And then finally, you want to look for burn marks. Are there any indications of outside stress or burning that show damage to the pole that might have reduced the integrity or caused it to not be suitable for whatever it is that you're about to try to do with it? So when we're looking at the general condition, and one of the first things that we're going to do when we start looking at the pole itself is we're going to look at the ground line. Is it buckling? Is the outside shell of that actually wider? Is there like a mushroom or buckling of that shell at the ground line? Does it indicate that there's actually been some type of compression or other deformation at the ground line that shows that you've got maybe a void or a rot pocket or a decay pocket in there somewhere that means that pole is not in as good a shape as it was when it was first put in the ground? You want to look for cracks, horizontal cracks, cracks that are perpendicular to the grain of the wood. Those can be significant. They are an almost immediate indication that your pole is no longer strong enough to be able to support what it is you're trying to do. Vertical cracks might not necessarily mean that the pole is not strong enough to support its load and do its job, but it certainly means that it's much more dangerous to climb. You don't want to be worried about getting your gaffs hung up in a vertical crack. You could think that you've got a good catch and you could cut out, or you could throw yourself in a different direction while you're trying to move. There's a lot of different things that can go wrong with vertical cracks. So you want to be aware of where they are. You want to avoid them when climbing, and you want to stay far enough away from them that you don't move the grain out into the void and have it cut out with you. Holes. Hollow spots and woodpecker holes can reduce the overall strength of a wood pole. And it doesn't have to be an old pole for this. Many of you have probably experienced new poles that didn't receive a good treatment or got put somewhere where the woodpecker population appears to be thicker than others, and you come back and a pole that's been in the ground less than 2 years looks like Swiss cheese when you get back. So you need to be aware of where those are, and just because they're not in the area that you're going to actually be climbing doesn't mean that they're not dangerous and can cause problems, because if it's up at the top of the pole or down below where the conductor actually attaches, that's a weak point. Stress and strain and changes could cause a breaking of the pole at that weak point, and then you got the conductor that's supposed to be in the air decides to come back down again. So you want to make sure that you go to looking for holes. Shell rot and decay, they can be indicative of overall age of the pole. It could be because of age, it could be a bad treatment, it could be conditions, it could be a number of things. Shell rot, decay on the outside of the pole, both of those make it problematic for getting good purchase for your gaff when you're climbing. They also indicate that after you lose a certain percentage of the overall diameter of that pole, it's no longer able to support the load. You can check your lineman and cableman's handbook, and it can tell you about how much of that percentage you can lose. Generally, you want to just consider that any significant amount of shell rot or decay indicates that you have a pole whose integrity has been reduced, and you need to take special precautions to protect yourself from it. Knots. One large knot or several smaller ones at the same height on the pole can be evidence of a weak point on the pole. They can definitely cause a point where you could break at that point under strain. So you want to be very aware of that grain in those knots, and if you look closely, you can tell that from the ground during your visual overall inspection. Depth of setting, evidence of the existence of a former ground line. Okay, if you look at the pole and it looks like you've got mud embedded into it from years and years, a foot above ground, you could have had erosion, you could have had excavation, you could have had floating of the pole, as any number of things could have happened. So you want to be aware of where it is. You want to check the birthmark. That birthmark is supposed to be 5 to 6 feet above ground level if you've set it according to the recommended depth. And so you want to check that birthmark, but don't rely solely on the birthmark. That it could be that part of the pole is rotted off or missing below ground level, and you really don't have that much of the pole that's in the compacted dirt. Soil conditions. Is it soft, wet? Is it loose soil around the base? Do you have an air gap around the pole where the soil is not remaining compacted? Has there been movement of the pole or movement of the soil? You want to check all of those conditions to see where they are. And burn marks could be from transformer failures, conductor faults, could be damage from lightning strikes or forest fires, could be any type of outside fire damage, could cause damage to the pole. You changing it from being a solid treated pole that can support the weight and you to charcoal that just won't do it anymore. So be very aware of burn damage and possible sources and what it's done to the pole itself. Burn damage in and of itself, it's just on the very surface, it's not a problem, but you can check that. You can flick that off with your prod or a cutting knife, and if it doesn't go very deep into the pole, then it's not a problem. But if it starts to go pretty deep, or it looks like it penetrates well into the pole, then you got a problem, and you need to make sure you take appropriate precautions to support that pole and whatever else that pole is supporting. Appendix D of 1910.269 and also in section N3 of 1910.268, which covers telecommunications, the methods for testing wooden poles are as follows. One of the following methods or an equivalent method shall be used. Shall be used. There's no option there. This is mandatory. It's not recommended that you do it just when you think there might be a problem. You're supposed to do this every time you're going to put a hook in a pole or if you're going to do work on that pole. Sound the pole and prod it, and or do a rock test of the pole. And we're going to talk about how you do each of those types of tests. Sound and prod the pole. This is from 268 N3I. Rap the pole sharply with a hammer weighing about 3 pounds, starting near the ground line and continuing upwards circumferentially, that's around the pole, to a height of approximately 6 feet. The hammer will produce a clear sound and rebound sharply when striking solid wood. The decay pockets will be indicated by a dull sound and or a less pronounced hammer rebound. When decay pockets are indicated, the pole shall be considered unsafe. It's pretty straightforward. Now, don't only rely on sound. I recommend that when you're sounding a pole, that you take your offhand and lay it against the pole away from the area of the hammer blow and feel that vibration. Understand what it is doing. Also, prod the pole as near the ground line as possible using a pole prod or a screwdriver with a blade at least 5 inches long. If substantial decay is encountered, the pole shall be considered unsafe. Now, as far as what you're going to use to prod that pole with, there are a number of tools that are made. There's one tool that's constructed that looks very much like your standard screwdriver, but it has a metal plate on the end of it that's specifically designed to take the strike from a hammer blow so that you don't damage or deface the handle of the tool. And the end of the tool is also set up to be a prod rather than a standard screwdriver blade. Now, this one is specifically designed to do that, but it is a good tool, and you can use a standard heavy bladed screwdriver to do that. You know, typically we want to use the correct tool for the correct job, but it is an acceptable industry practice to use those heavy-duty screwdrivers for this purpose. Now, rock testing the pole. How do we go about rock testing a pole? Well, it's pretty straightforward. You do it perpendicular to the line. Why do you do it perpendicular to the line? Well, one of the main reasons you do it is because it puts you out from under the conductor. And if you rock test a pole and the conductor fails and falls, you don't want it to fall on top of you. Also, the conductor typically guides it. If you've got a line that runs north and south, the conductor will guide it north and south. So you want to try to rock that east and west. Now, you don't want to shake it as hard as you can. You don't want to put a vehicle or anything else on it to do it, to put strain on it. You want to try to do it personally. And one of the first steps you're going to do is you're going to do a visual inspection. And if you, in that visual inspection, before you ever put a hammer or a prod to the pole, you see that there's potential for falling objects up there, you don't want to do the rock test using your hands. You want to use a pole gaff, or you want to try to use a rope. And you can take that rope and you can put a slip loop in it. You can use a stick or an extendo stick to run it above your head as high as you can get it, and then tighten up on that rope. And then you can, starting gently and then getting successfully better, do multiple tugs on that pole to rock it and see what happens. If the pole moves significantly, if it begins to pop or crack, if it begins to lean or otherwise indicate that it's not secured in the ground or has a weak point on it somewhere, then you need to stop the rock test immediately, and you need to take steps to secure that pole while you get ready to replace it. Apply the N32I states, apply a horizontal force to the pole and attempt to rock it back and forth in a direction perpendicular to the line. Caution shall be exercised to avoid causing power wires to swing together. In other words, you don't want to swing it so hard that you slap the conductor lines together. You just want to move it enough that you can tell whether or not the pole is moving and whether or not it's got weak points or broken points in it. The force may be applied either by using a pike pole or by pulling with a rope. If the pole cracks during the test, it shall be considered unsafe. That's not only audio sound of a cracking sound, but also if you begin to see any separation in the grain or movement on it. You want to consider that to be unsafe. Let's back up a little bit. Before we ever start putting a hammer or a prod on the pole, before we tie a rope to it and start rocking it, we're going to do a visual inspection of the pole and all the connections around it before we ever approach it and get under it. Now, we're obviously going to be wearing a hard hat for falling object, but that's not going to protect us very much against energized conductor or heavily loaded cables. So before testing that, we're going to check for loose, broken, or misaligned equipment. Is it hanging the way it's supposed to? Is it out of alignment? Does it look like one or more of the bolts or pieces of hardware are missing or jutting out from the pole farther than they're supposed to? Check the ground. Look for loose bolts or equipment. Look for porcelain pieces. Look for pieces of pole or dressed and treated wood that may have come from a broken crossarm brace or something like that. Look around the pole to see what else might be there. Check for visible cracks or holes or breaks in it. Check the height of the birthmark. Again, it needs to be 5 to 6 feet up. Check the ground around it for gaps. Is it moving? Is it on a hillside, and has the dirt slid down the hill and the pole is no longer vertical but leaning according to the way the hill is gone? Look at the surrounding conditions, the overall condition of the pole, and let that dictate how you go about completing the rest of your inspection and test on the pole. When you're sounding the pole, here's a couple of key points to remember. You want to use a hammer that weighs about 3 pounds. Now, some of the heavier ball peen type hammers are really good. Heavy roofing hammers, there are some malls that are specifically designed, or small testing hammers that are specifically designed for sounding poles. But standard claw hammer or small ball peen, that's not going to get it. You need to get something that's going to put a pretty good strike to that pole so that you get a good sound on it, and make sure that you get a good enough stress on it that it'll tell you what you've got. Start at the ground line and work up at least 6 feet. Okay, that doesn't mean you hit it 6 times and you're done. You want to check all the way around the full circumference of that pole. So let's say you divide that into quarters, and you start at the ground line and you do a strike every foot. That's 6 strikes in each of the 4 quarters. That's 24 strikes. Now, you might think, Mike, that's an awful lot of banging on that pole. Yes, it is, but it doesn't take you a minute to do that kind of work, and is that worth it? Just because it sounds solid on one side doesn't mean it's going to be solid on the other. And you want to make sure that you get it covered up all the way through. So, 18 to 24 strikes is definitely what you want to be running on that. You might break it up into thirds for the smaller poles, but definitely those bigger Class 1 and Class 2 poles, you want to be working all 4 quarters, and you want to make sure that you're doing at least 6 strikes per quarter to make sure you get good solid sounding on it. When you're prodding that pole, you want to go, and again, you're going to divide that into quarters. You're going to go at ground level, and you're going to go in at about a 45-degree angle. You're going to try to drive that screwdriver an inch or 2 into the pole all the way around. If you start getting real deep in any one spot and find a decay pocket, then you need to back off and take another look at that pole and start to really strongly suspect the integrity of that pole and whether or not it's going to start up. Start as near the ground line as possible and go around 4 to 6 locations. When you're rock testing the pole, the key points are apply horizontal pressure to the pole to rock it from side to side perpendicular. This is not shake it as hard as you can shake it. This is put a strain on it, release it, try to rock it so that it'll move, and find out whether or not that it's going to make any sounds or breaks. You'd much rather, if you're pulling it with a rope, you'd much rather it break while you're 30 feet away from it than right up against it or on it. Take precautions to avoid getting energized conductor together. Again, be careful about how you slap it together. It doesn't have to shake it hard, just move it enough to test the integrity. Watch the ground line. Okay, is there any part of the pole that looks like it's staying vertical while another part of it is moving? That's an immediate telltale sign you got a weak spot in the pole. And again, use a rock or a pike pole to be able to make that pole move perpendicular to the line. When climbing or working on wooden poles, knowing the condition and ensuring the soundness of the pole is absolutely critical. If you are in doubt or have any reason to suspect that rot or the structural integrity is compromised, take steps to secure or support the pole with ropes, guys, or a digger derrick, and work it with a bucket. Work it. Don't get up on that pole, no matter how strong you got it tied down. You need to make sure that you do what you got to do to protect yourself, and you've got to do it every time. So let's summarize what we're talking about. Always check a wooden pole or structure before climbing or working on it. No exceptions. Don't skimp. Conduct a complete inspection and test all the way around and as high as you can reach. Don't make assumptions. Birthmarks and inspection tags will not guarantee a sound pole or structure. Just because it was looked at by somebody else 2 years ago, or just because it was only put in the ground 2 years ago, doesn't mean that it's still ready to climb. The pole could be perfectly good, but the ground you put it in is completely rotten. The pole could look good on the outside, but something about the treatment didn't take, and the varmints and critters have just hollowed it out to the point inside that it's like a paper straw. So you've got to make sure that you take your own safety into your own hands. You don't rely on anybody else, and you do a complete test before you begin to change the strain or climb on that pole. Do what you've got to do to get home to your family safe at the end of the day, every day. Now, I hope this has been helpful to you. I hope everybody really takes this message to heart. We have way too many people in the state of Tennessee that have been hurt or injured due to falling poles when they could have so easily been avoided by doing a thorough and complete inspection of that pole before doing any work. This is not just for if you're going to put hooks on and climb a pole, or if you're going to be working out on a main line with a pole. If you're going to put a ladder on a service pole and cut a service down, if you're going to change a conductor, if you're going to add a guy, or you're going to tighten a guy, or you're going to increase the number of conductors, or add another run of a primary line, all of these indicate that you're changing the stresses and strains on that pole, or worse yet, removing the stresses and strains that are acting as guys to hold it. And so you need to know where it's going to go, and you need to be prepared for that. Again, I hope this has been beneficial to you. I hope you all will be safe and make sure that you do the things that you know to do to make everything better for you and your coworkers, and most of all, to get home to your families at the end of every day. Thank you, and be safe.